Dobry din means hello in Belarusian. I'm Sofia. The people of Belarus are sincerely grateful to you for following an eco-friendly and vegan lifestyle. Welcome to our program, Intelligent and Sustainable Housing Solutions, Part 2 of 3. The construction of conventional houses consumes a vast quantity of raw materials, thus creating a huge environmental footprint. To help resolve this issue, new trends in small sustainable housing have emerged. The Ecocapsule is a smart, self-sustainable microhouse that uses solar and wind energy for power. The energy-efficient egg-shaped dome, designed by a Slovakian firm, Nice and Wise, which allows its inhabitants to live off-grid and enjoy the scenic beauty of nature. The exceptionally compact, low-energy, mobile dwelling is cleverly packed into an egg-shaped form that can be placed almost everywhere. Made of steel and fiberglass, the Ecocapsule comes with a 750-watt wind turbine and 880 watts of solar power connected to a 10-kilowatt battery. Water is collected from the roof and then run through a reverse osmosis filter. The little home measures only 15.32 feet, 4.67 meters in length, 7.22 feet, 2.2 meters in width, and 14.76 feet, 4.5 meters in height. This compact size enables the Ecocapsule to be easily transported to any location, making it an enjoyable home for free-spirited explorers who love moving around. Ecocapsule can comfortably host 2 adults and features a built-in kitchenette with running water. The structure also contains a dry separating toilet, a hot shower, a folding bed, and plenty of storage space for sporting goods or other types of equipment. An architect, Sona Polova, the founder and director of Ecocapsule, stated that you can live almost anywhere. If you live in Australia and have a lot of sun but not so much wind, it will be sufficient with just the sun. While, on the other hand, somewhere like the Netherlands, there is lots of wind and less sun. She further explains, mostly, we want to get you out to feel connected with the beauty around you. Ecocapsule can also be used as a cottage, a micro-hotel, a travel trailer, a mobile office, or a research station. In a second example, a group of students constructed the waste house at the University of Brighton, UK, from a variety of waste materials obtained from domestic and construction sites. The frame and floors of waste house are made of recycled wood, and 10 tons of chalk waste from another construction site were collected, pounded remnant earth style to form a wall. This innovative, low-energy home was constructed by approximately 360 students and volunteers, some as young as 15 years old. The construction started in May 2013 and was completed in April 2014. The inner walls of this house are filled with blocks of insulation made from throwaway items such as 20,000 used toothbrushes, thousands of floppy disks, DVD cases, and tons of denim waste. Discarded vinyl signs were reused as vapor barriers all around the structure, while 2,000 old carpet tiles were used as exterior cladding. A series of sensors in the external walls of waste house will monitor the home's insulation properties at key points and measure just how efficiently the different materials perform. The Brighton Waste House was designed by senior lecturer and architect Duncan Baker Brown. In September 2015, Waste House was nominated for the Royal Institute of British Architects Stephen Lawrence Prize. We sincerely wish that the brilliant example of the Waste House can help lay the foundation for a new wave of sustainable architecture and housing. Kudos to architect Duncan Baker Brown and the students and volunteers who helped to build Waste House for providing a creative example of reusing discarded materials. We'll now travel to Estonia to look at another inspiring eco-friendly housing design. Koda is a sustainable and portable two-story mini house with built-in IT that enables the structure to learn from and adjust to its surroundings. The house was developed by Koda Oy, an architectural and engineering company based in Estonia. Koda is a home that has all the necessities for living while addressing global concerns about growing population rates and the related demands for affordable living units. The Koda home occupies a 26.4 square meter floor space containing a living room, a kitchen, and a bath shower facility, along with a bedroom and laundry room upstairs. Solar panels are mounted on the roof to generate power, and inside are smart home devices including alarms, adjustable LED lights, and climate control equipment. Large windows and quadruple glazing maximize heat and light, and many components can be customized to best fit any given purpose. According to Mr. Uller Mark, a co-founder and system architect of Koda, 31 Koda modules have been built and installed in several European locations for different uses. He further explains, there is a great advantage in using Koda modules for public buildings. The modules can be easily relocated and repurposed once they are no longer needed at the original location. Let's next explore an exciting, self-sufficient, eco-friendly house called Earthship, whose designer is renowned architect Michael Reynolds. Essentially, Earthship homes are built with recycled materials such as rubber tires, glass bottles, aluminum cans, and other repurposed waste. Mr. Reynolds took cans, wired them together into bricks, which were then cemented together and plastered over, rather than using energy-consuming recycling methods to break down the cans as a whole. Mr. Reynolds calls this method Earthship biotexture. The old tires were made into a powerful thermal mass by filling them with soil, hence making the room created from these materials cool in summer and warm in winter. Solar panels were later introduced to Earthship's designs along with geothermal cooling. Well organized as enabling sustainable lifestyles, Earthship biotexture is constructed based on the following key elements: building with natural and recycled materials, installation of renewable energy systems, thermal, solar heating and cooling, rainwater harvesting and filtration, self-contained sewage treatment, and plant food production within the structure itself. now present another sustainable house featured on today's show. Sukup Safe Tea Homes are a line of interesting dwellings designed specifically for disaster-prone areas where earthquakes, hurricanes, high winds, and storms are frequent or severe. The Sukup Manufacturing Company and GoServe Global, an Iowa, USA-based philanthropic organization, combined forces to provide this innovative way to bring disaster relief and comfort to families around the world. The Sukup Safe Tea Home is a highly modified grain bin that is resistant to earthquakes, termites, and moisture. Grain bin houses or silo homes provide refugee housing for families who need a safe place to live. While Sukup deals with manufacturing the homes, GoServe makes sure they are put to good use in remote villages. Sukup Safe Tea Homes collect rainwater from their roofing systems while deflecting heat and providing ventilation to keep the interior cool. The all-steel tea home construction is fireproof and termite-proof and should last for 75 years. The overall structure stands 13.5 feet 4 meters from floor to roof peak, and the side walls are 8 feet 2.4 meters tall. With their round shape, the units can withstand high winds and earthquakes. Any unskilled person can assemble the tea home as it's extremely easy to set up. Apart from security and comfort from the effects of weather provided to disaster-stricken inhabitants, tea homes can be purchased at a highly affordable price. In October 2016, the Sukup tea homes built in Haiti, which protected the country's residents from Hurricane Matthew, one of the most powerful Atlantic hurricanes in recent history. The executive director of GoServe Global, Mr. Paul Van Gorkom, said, "When Hurricane Matthew hit, we are very happy to say that all of our safety homes, which is nearly 200 in Haiti now, are still standing. We are grateful to the talented and considerate architects who are greening the housing solutions. May God bless you." Loving viewers, thank you for being with us today during our program, Intelligent and Sustainable Housing Solutions Part 2 of 3.